Welcome PreCalc to 2/8/17 edition. So that's Wednesday after class edition. And we're going to be studying a new topic, and that is binomial expansion. What in the world is binomial expansion? I think you might have had this. So hopefully, I'm going to take a binomial. Binomial is two terms added together. That's a binomial. And I'm going to raise it to the zero. Well, anything to the zero, oh math student, is 1. So, by definition, so a plus b to the 1, and now I'm going to raise it not to the 0, but to the 1. And I'm going to get a plus b unaltered. Now we'll get to have some fun. A plus b squared, a plus b times a plus b, and we have a distribution, 4 different steps, and we're going to get a squared plus ab plus ba, which I'm going to write as ab, plus b squared, like terms to be combined. So we end up with a squared plus 2ab plus b squared. Now, I would like you to be able to go from here to here and skip the who struck in between, because whenever you square a binomial, it's always this squared, so you got that part and that piece, and the middle term is always this times this doubled. Doubled means times 2, so a times b doubled, or times 2, is 2ab. Alright, I think you recall that tip from your math past. Now, we're up to 3. What we're doing here is expanding binomials. We're going to raise it to successively larger powers. So, a plus b to the third is going to be a plus b times a plus b to the second. And because these exponents are added to get this one, so these are equivalent statements, but we already have a plus b squared. Here's the things we're going to study. So I'm going to rewrite this a plus b times, and when I get to a plus b squared, I'm going to put in what I've figured out in the step before. Alright, now we have a longer dance. We got 3 steps here and 3 sets there. So, hey, it's going to get worse before it gets better, but it is going to get much better. A cubed, 2a squared b, ab squared. I am going to write b times a squared as a squared b. Uh, 2ab squared and b cubed. Alright, so now we can combine like terms. There's no other a cubes, but there is another a squared b. So we have 2 and 1 of those, and we have 1 and 2 of those, and then only 1b cubed. So I combined like terms, and that is a plus b cubed. Alright, let's do one more the long way. Then I get to show you the short way. Alright, a plus b to the fourth, expanding we go, is a plus b to the 1 times a plus b to the third, but we just did a plus b to the third, so I'm going to put that in for that. And expand away. Alright, here we go. we're going to have 8 steps this time. So I'm going to distribute the a down through the ranks here. A to the 4th, 3a cubed b, 3a squared b squared, and ab cubed. I like to get this on one line. Let's see if I can fit it on. ba cubed, I'm going to write the a cubed first. 3a squared b squared. 3ab cubed. And b to the 4th. Alright, finding like terms. There's 3. And there is 1. I'm going to kind of cross them out. Not that they're gone, but then I know I've combined them. 3 of those and 3 of those. And 4 of those. And a b to the 4th. All right. So my goal tonight is to show you how to raise a plus b to the 5th, 6th, 10th, 12th, whatever, in a much quicker way than all of this. So we're going to study this to see some patterns. So if you ignore the numbers, which I call coefficients, you can see, like when we raised this binomial to the 2, a appeared to the 2. A was squared. Then a went down 1, and it was now a to the 1, and b appeared to the 1. In the last term, there was no a term at all, and b went up. See if that pattern repeats. When we raised it to the 3rd, a appeared to the 3rd. That's the maximum exponent we're going to see. And then, not looking at these numbers, but just at these letters, notice a went down from 3 to 2, and then b appeared. So that's like a 1. Then a went down again, and b went up. And then a disappeared, and b went up. So you can see a is descending in its exponent, while b is ascending. Does that hold true for this one? Here, a to the 4th, a to the 3rd, a squared, a, no a. See what happens to b. No b, 1b, b squared, b cubed, b to the 4th. All right. So that pattern will serve us no matter what we're trying to do with the binomial. So I think I will anticipate what a plus b to the 6th is. I sure will get a chance to do a plus b to the 5th, but a plus b to the 6th. So we know then there's going to be some number, and we'll learn what that is. A will appear to the maximum exponent. B will not appear in that term. Then there'll be some number. Then A will go down to the 5th from the 6th, and B will appear. All right. Then we will take A and reduce its exponent by 1, and B will increase. Then A will go down again, and B will go up again. Then we will have a down to the 2nd, b up to the 4th, a down to the 1, b up to the 5th, and no a, all b's to the max, 6. All right, so you see it's not that hard to come up with the expressions without all of the distribution. So now how do I relatively quickly get these numbers? We're going to find them in what's called Pascal's Triangle. And we start with a mountain of 1s. So here's the peak of the mountain, and there's 2 ones on the base of the mountain. That's how Pascal's triangle starts. It's a triangle of ones. Now, each row in Pascal's triangle starts with a 1 and ends with a 1, but the numbers in between can be found by adding the 2 above it. So this one will be 1 plus 1, and then I end with a 1. I'm going to start the next row with a 1, add the 2 above it, and end with a 1. All right. 1, 4, 6, 4, 1. And if you notice, those numbers look familiar. They actually appeared when we did this expansion right here. The coefficient here is 1 unwritten, 4, 6, 4, unwritten, 1. So we're going to take this down another 2 rows. So we have 1, 5, 10, 10, 5, 1, and 1, 6, 15, 20, 15, 6, 1. All right, I have to go as far on Pascal's triangle as necessary to get the number that matches the number of blanks in my problem. So I have 1, 2, 3, 4, 5, 6, 7 blanks. And this last row is 1, 2, 3, 4, 5, 6, 7. It's a match. So the number will go in each blank. So I'm going to put a 1 in the first one, and 6, 15, 20. And then 15, 6, 1. And the 1 I put in for emphasis, I don't need to really write it. This is the correct answer for the expansion of a plus b to the 6th. So it's a plus b times 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 a plus b. It's a lot of work, but when you notice the patterns, it becomes a rather quick task. All right, we're going to work on that tomorrow and do some binomial expansions. So bring this knowledge with you. Do not leave it behind. Till then, over and out.